Hi friends, in this video we are going to solve the packet tracer activity, pinging and tracing to test the path. Before coming to this packet tracer activity, friends, if you are watching our channel first time or if you like to get these type of technical videos, consider subscribing. Also, don't forget to enable that bell icon near the subscribe button so that you will get the notification message whenever we upload a new video. Right, now we will come back to our packet tracer activity. Here we can see our addressing table. Also objectives. In part 1 we will test and restore IPv4 connectivity. In part 2 test and restore IPv6 connectivity. We will go to part 1 test and restore IPv4 connectivity. Step 1, use ipconfig and ping to verify connectivity. Click PC1 and click the desktop tab, command prompt, enter the ipconfig /all command to collect the IPv4 information. Complete the addressing table with the IPv4 address, submit to mask and default gateway. Yes, we can do that. Coming to PC1, desktop, here we will go to command prompt. We will give the command ipconfig /all. And here we can see the details. Here we can see IP address. We will copy this address. Coming to our spreadsheet, PC1 IPv4 address. Here is that. Here we can see the submit to mask. It's here. Then the default gateway. We will copy it. It's ready. In the same way, we have to get the IP address details from PC3 also. Here we can see PC3. We will click on PC3, desktop, command prompt, and here we will give the command ipconfig /all. And here we can see IP address details. IP address, we will copy this and coming to our spreadsheet. This is PC3. Here is that. Here we can see the submit to mask for this PC3. Then the default gateway. It's here. Right. Next, test connectivity between PC1 and PC3. The ping should fail. Okay, right. So we will ping from PC1 to PC3. We will get the IP address of PC3. Here is that. Coming to PC1, command prompt. We'll press Ctrl C. Here we are going to give a ping to PC3 IP address. Here we can see a destination host unreachable. Request timed out. And here we can see the details. Packet sent 4, received 0, lost 4, and here we can see 100% loss. So it's failed. Now we will go to step 2, locate the source of connectivity failure. From PC1, enter the necessary command to trace the route to PC3. What is the last successful IPv4 address that was reached? Okay, we will try that. Okay, now we are going to trace from this PC1 to PC3. Coming to PC1, command prompt, and here we are going to give trace it, then the PC3 address. So here we get this address at 10.10.1.97. Any other address? So it's a request timed out. Again we get this 10.10.1.97. So here we can see the last successful IP address reached is at 10.10.1.97. Next is the trace will eventually end after 30 attempts. Enter Control C to stop the trace before 30 attempts. Okay, here we will press Control C and it stopped. Next, from PC3, enter the necessary command to trace the route to PC1. So we are going to trace from this PC3 to PC1. Okay, what is the last successful IPv4 address that was reached? First of all, we will get the IP address of PC1. It's here. Coming to PC3, command prompt. And here we are going to give the traceed command, and the PC1 IP address, it's here. So here we can see the IP address at 10.10.1.17. Here we can see the last successful IPv4 address reached is at 10.10.1.17. We will press Ctrl C and we will stop this trace. Now click R1 and then the CLI tab. Press enter and log into the router. Enter the show IP interface brief command to list the interface and their status. There are two IPv4 addresses on the router. One should have been recorded in step 2A. What is the other? Okay, we will find it out. Coming to R1 CLI tab, we will press enter, enable, and here we will give the show command, show IP interfaces brief, and here we can see the details. Here we can see IP address for the interface gigabit Ethernet 0/1 10.10.1.97. This is the IP address what we have seen in the first traceset. And here we can see the other IP address. It's a 10.10.1.6 for the interface serial 0/0/1. Next is enter the show IP route command to list the networks to which the router is connected. Note that there are two networks connected to the serial 0/0/1 interface. What are they? Okay, we will give this a show IP route command and we will verify that. Here we will give a show IP route, and here we can see the details. Okay, here if you observe this output, we can see two networks are connected to this interface serial 0/0/1. Here we can see those. One is a 10.10.1.4/30 is directly connected to serial 0/0/1. Also we can see 10.10.1.6/32 is directly connected to serial 0/0/1. Okay, so repeat step 2E to 2G with R3 and record the answers here. Yes, it can be done. So we will close this R1. Now we will go to router R3, then CLI, press enter, enable, and here we are going to give the command show IP interface brief, and here we can see IP address details. Okay, and here we can see the IPv4 address what we had seen in the second traceset. It's 10.10.1.17, and the other IP address is at 10.10.1.10 for the interface serial 0/0/1. Also, now we will give this show IP route command for this router R3. Show IP route. And here we can see the details. Yes, here also we can see two networks are connected to this serial 0/0/1 interface. It's a 10.10.1.8/30 is directly connected to serial 0/0/1, and here we can see 10.10.1.10/32 is directly connected to serial 0/0/1. Okay, what is next? Notice how the serial interface for R3 changes. Yes, we have seen that with this router R3. Run more tests if it helps visualize the problem. Simulation mode is also available. Okay, so now we will go to R2. We verified on R1 as well as R3. We will go to R2 and CLI. Here we will verify. Show IP interface brief, and here we can see the address details. Coming to our addressing table, R2 for the interface 00/0/0. Here we can see IPv4 address. It's a 10.10.1.5. But coming to our show output, here we can see for this interface serial 0/0/0, they set the IP address incorrectly. They're given here a 10.10.1.2. It should be 10.10.1.5. Okay, now we will go to the next step. Step 3. Propose a solution to solve the problem. Compare your answers in step 2 to the documentation you have available for the network. What is the error? Yes, just now we have seen on this router R2, they set the IP address incorrectly for the interface serial 0/0/0. What solution would you propose to correct the problem? Yeah, we have to we have to reset this IPv4 address. Next is step 4, implement the plan. Implement the solution you proposed in step 3b. Okay, nothing else. We have to reset this IPv4 address for this interface serial 0/0/0 on this router R2. So as per our addressing table, here we can see it's 10.10.1.5. We will correct it. We will go to that interface serial 0/0/0, configure terminal interface serial 0/0/0, and here we will set the IP address. We already copied that address. Here is that. Then the submit to mask, it's a 255.255.255.252. Okay. Now we can verify it. Show IP interface brief. And here we can see the correct IP address now for the interface serial 0/0/0. Coming to step 5, verify that connectivities are restored. From PC1, test connectivity to PC3. Then from PC3, test connectivity to PC1. Is the problem resolved? We will verify that. We will go to PC1 and we will ping to PC3. We will press the up arrow. Here we can see the ping command 10.10.1.18. Yes, we get the replies. It's working. Now we will go to PC3 and we will ping to PC1. Command prompt. And here also we'll use the up arrow. Okay, we will not ping from this PC3 to PC1. We will get the IP address of PC1. Here is that. We will copy this address and coming to our command prompt, here we will give a ping to PC1 address. It's working. We get the replies. Yes, our problem is resolved. So now we will go to part 2, test and restore IPv6 connectivity. Step 1, use IPv6 config and ping to verify connectivity. Click PC2 and click the desktop tab, command prompt, then enter the IPv6 config /all command to collect the IPv6 information. Complete the addressing table with IPv6 address, subnet prefix and default gateway. We will go to our PC2. Here is that desktop command prompt. Here we are going to give IPv6 config all, and here we can see IPv6 address details for this PC2. It's here IPv6 address. We will copy this address and coming to our spreadsheet PC2. Now we have to get the default gateway. It's here. Ready. Also we have to verify this IPv6 address, subnet prefix and default gateway for PC4 also. Coming to our PC4 desktop command prompt, here we will give the command IPv6 config all, and here we can see the details. Here we can see IPv6 address, so we will copy this address. Then coming to our spreadsheet PC4, here is IPv6 address. Then this subnet to mask, it's here. Okay, our addressing table now complete. Now test connectivity between PC2 and PC4. The ping should fail. Okay. We will get IPv6 address for PC4. Here is IPv6 address. We will copy this address. Now we will go to PC2 and we will ping to PC4. Ping to, here is a PC4 IPv6 address. Okay, we are waiting for the replies. No, it's not working, it's failed. Okay, what is next? Step 2, locate the source of connectivity failure. From PC2, enter the necessary command to trace the route to PC4. What is the last successful IPv6 address that was reached? We have to verify that. We will go to PC2 command prompt, and here we will trace it to PC4, and here is the IPv6 address for PC4. And here it got stuck. Here we can see the last successful IPv6 address reached. It's 2001:db8:1:3:2. Okay, we will press Ctrl C and we will stop it. Now in the same way we will trace it from PC4 to this PC2. We have to get the IPv6 address for this PC2. It's here. We will copy this address. Coming to PC4 command prompt, and here we will give the traceset command, and here is the PC2 IPv6 address. We are waiting for the result. Request timed out. Here, what is the last successful IPv6 address that was reached? Here we can see we did not get any IPv6 address. Enter Control C to stop the trace, as we already stopped it. Click R3 and then the CLI tab. Press enter and log into the router. Okay, then we will close this window. Then enter the show IPv6 interface brief command to list the interfaces and their status. There are two IPv6 addresses on the router. One should match the gateway address recorded in step 1D. Is there a discrepancy? Now we will go to R3 and here we will give the show command. Enable show IPv6 interface brief, and here we can see interface status. Here we can see the interface gigabit ethernet 0/0. This is the default gateway for this network, and here we can see that IPv6 address, the default gateway 2001:db8:1:4:1. And here we can see they say that we have to match the gateway address recorded in step 1D. So that is nothing but the command what we given is IPv6 config in this PC4 command prompt, and here we can see the details for this command, and here we can see the default gateway. It's FE80:2. And once more, here we can see this network is connected to the interface G0/0 on this router R3. So we will verify the link local address on this router R3. Here we can see the interface G0/0, and here we can see it's FE80:3, but here it is FE80:2. We can see the default gateway on this PC4 they set incorrectly. Okay, coming to step 3, propose a solution to solve the problem. Compare your answers in step 2 to the documentation you have available for the network. What is the error? As we have seen on this PC4, the default gateway set incorrectly. And what solution would you propose to correct the problem? Obviously, we have to change the default gateway for this PC4. Step 4, implement the plan. Implement the solution you proposed in step 3B. Okay, we can do that. It's quite simple. We have to go to PC4, then IP configuration, and here we can see IPv6 configuration. IP address, IPv6 address, it's correct. So only we have to change this IPv6 gateway. It's FE80:3. Finally, step 5, verify that connectivity is restored. From PC2, test connectivity to PC4, then from PC4, test connectivity to PC2. Is the problem resolved? We will verify that. Coming to our PC2 command prompt, and already we ping to PC4 from PC2, so we'll press up arrow. Here is that. It's working. We got the replies. Now we will ping from PC4 to PC2. So we have to get the IPv6 address of PC2. It's here. Coming to PC4, command prompt, ping to PC2. Here is the IPv6 address. It's working. We got the replies. Great. Here we can see the completion status 20/20. So here we solved a packet tracer activity, pinging and tracing to test the path successfully. Friends, just stay tuned and we will meet again with the next video. Thank you.